Good evening everyone. So welcome to the next video, today's video, this problem and its solution, which was to be put on 5th September. Um, so this problem states in an experiment, an air rifle pellet is fired into a block of modeling clay that rests on a table. So you are now shooting a pellet, a bullet for example, on this clay block. The air rifle pellet remains inside the clay block after the impact. Okay, and then so it is stuck inside this, right? The moment you say there's something like this, it is remains inside the clay block. What kind of question is this? It's a question on collision. And moreover, what is it happening over here? You have a bullet, it was moving, a bullet which was moving with, it is a mass m and it moved with a velocity u, and this was stationary, which means this was u1 and this velocity was u2, which was equal to rest, and after colliding it started moving over here with a common velocity v, right? Okay, now let us look at the problem. As a result of collision, the clay block slides along the table in a straight line and comes to rest. Okay, so now it starts moving over here, but it comes to rest after some time. Why does it come to rest? Could be there is some frictional force over here. Okay, see, before even reading the parameters, we are arriving at, okay, what could be the problem. Then further data related to experiment are given below. Mass of the air rifle pellet. Okay, so the mass of the bullet in our simplest terms is given to you. Mass of the clay block. So this is nothing but mass of the clay block. Then velocity of the impact of the air rifle bullet. So this is your velocity, initial velocity u1. Then stopping distance of the clay block. So this is also given to you. Okay. So now what is being asked? Show that the initial speed of the clay block system after the air rifle pellet strikes it is 4.8 meter per second. So which means what? So when you have the bullet whose mass was m and its velocity, that is mass was, I will write out the values over here, 2 grams, and its velocity was 140 meter per second, and when it hit the clay block, okay, whose mass was 56 grams and its velocity was 0. Now the clay block started to move, and the total mass was seen to be, it was stuck inside it, right? It was stuck inside it. 56 plus 2, 58 grams over here, and the velocity is unknown. We need to find this velocity v. Okay, so how do I do? Conservation of momentum. What kind of collision is this? Inelastic collision. Okay, so we have diagrammatically drawn the situation. Now we have 2 gram multiplied by 140 plus 56 grams multiplied by 0 should be equal to, after collision, 58 grams multiplied by v. So what do I need? I need only v here. The v should be equal to 2 grams into 140 divided by 58 grams. Gram goes away. So then let us calculate what is this 140 by, so let me take up the calculator. So 2 star, put it upwards, okay. 2 star 140 divided by 58. So answer comes out to be 4.827. 4.827 meter per second. So which can be one significant figure, you can write this 4.8 meter per second. So this will be your answer, right? Let us look at the next question. Calculate the average frictional force that the surface of the table exerts on the clay block. Now when the clay block is moving, let me go back to the figure. When the clay block is moving, now what does it do? The clay block starts from here and it goes to a given distance and it stops here. Why does it stop? Because friction. That means whatever energy this had, all the energy is lost due to the friction, right? Now let us find out what is the velocity of this combined system. The velocity of the, the energy of the combined system. The energy of the clay plus the bullet should now be equal to half into, what is the mass of it? 58 grams. 56 plus 2, right? 58 into 10 to the power of minus 3 multiplied by v. What is v? 4.8 square. 4.8 square. So when you do this, what is the answer you get here? Okay. So this should be, we move this a little bit upwards so that we can see this. So I get the answer as 4.8 star 4.8 star 58 divided by 2 is equal to 668.16 into 10 power minus 3. 668.1 or maybe 2 into 10 to the power of minus 3, or this should be equal to 0.68 joules, right? So this is what I should get over here. Now what is this now? This is the energy of the clay block system. Now as a result of this energy, it starts moving and comes to rest. Now all the energy is dissipated as friction. The work done by the friction is frictional force multiplied by displacement. What is the displacement is given? Displacement given here. Displacement, what does it say? It says the distance moved by the object while it moves. Where is it? It's not given anywhere here. It's given here. As a result, it comes to this 2.8 meters. See, it hit here, it moved by 2.8 meters. So therefore, let me write this as F into 2.8 meters is equal to 0.68. Or the frictional force here should be 0.68 divided by 2.8. How much will that be? That will become 0.68 divided by 2.8 meters is 0.242. This is 0.24 Newton. What is this now? This is your frictional force. Frictional force which acted over here. Now see, this is for 4 mark over here. So how do you divide this mark over here? The first one is you need to find out the total energy. So this will give you 1 mark, or maybe calculate the average frictional force, right? So this you will get 2 marks over here, and this you will get 2 marks over here. Okay, so concept wise you will get 1 mark here, and this will be a 1 mark final answer. So this is how the breakage has been given. Just don't do only the calculations and give the answer. You should do something like this. Okay, so thus we are able to complete 6 marks, 4 plus 2, 6 marks in nearly how much? 13 minutes we chosen, right? Okay, so 7 minutes. Anyway, I will stop here and let me make a new video for the rest of the problems.